So first we'll understand that why quantum mechanics is required. Classical mechanics, we know as per the Newton's law of motion, it describes the motion of only the macroscopic objects. That means objects whose weight or mass is more. That means example is the falling of stone, planet, that means orbiting planets. And this already I described in the previous class. But when the particle is very minute mass level, that's for electrons, atoms, molecules, all are called the microscopic objects. Microscopic objects means whose mass is very less. We usually tell it is the subatomic level. So this microscopic objects motion cannot be explained by this classical mechanics. And so the quantum mechanics have came in the picture. Here you can see that this is mainly because of the fact that classical mechanics ignores the concept of the dual behavior of matter. In the previous class, I discussed about the dual behavior, that means wave and mass. This is the dual properties of any matter. And the Heisenberg's uncertainty principles. So these two concepts, that means dual behavior, wave particle nature, and the Heisenberg's uncertainty principle for the microscopic objects does not considered as per the classical mechanics. And that is the reason why quantum mechanics has been evolved. Now we'll discuss about what is quantum mechanics then. The branch of science that deals with the dual behavior of the matter, it is called the quantum mechanics. Quantum mechanics is a theoretical science. Quantum mechanics is a theoretical science. It is not the practical science. And it deals with the microscopic objects. This term always you have to remember. Because microscopic objects both has the wave-like and particle-like properties. And this quantum mechanics specifies the laws of the motion of these microscopic objects. When quantum mechanics is applied to the macroscopic object, that means heavy object whose mass is heavy, large mass. So in that case, actually, that particles or objects wave character is very insignificant. And in that case, this quantum mechanics will be equivalent to the classical mechanics. So for the macroscopic objects, classical mechanics will also be as quantum mechanics, because in that case, the wave-like properties is not exist or very insignificant. That means dual properties of the matter will not be considered for the macroscopic objects, what I already said now. Now, we'll check the background of the quantum mechanics, because for every invention, there is some backgrounds. We need to know this to generate the interest of this subject, that means quantum mechanical model of atom. What is this? In the year 1926, two scientists, physicists mainly, Heisenberg and Schrödinger, they developed the quantum mechanics. And this quantum mechanics will be based on the ideas of the wave motion, what I already said. The fundamental equation of quantum mechanics, it was developed by the Schrödinger, and he got the Nobel Prize in physics in the year 1933. And this fundamental equation incorporates that wave-particle duality of matter. When we will discuss about the quantum mechanical model of atoms, always we have to remember, we have to introduce the words wave-particle duality of matter, as proposed by the de Broglie, and it is very much complex subjects. And for this, we need the higher mathematics help, that means the knowledge of the higher mathematics. But in this class, it is not required the solutions, and this will be solved in the higher classes. So in this class 11 chemistry class, this is not required. Only now we'll know some term of the quantum mechanical model. For a system, the Schrödinger equation was written where the mathematical operator, which is called the Hamiltonian. So this term you have to remember. Schrödinger gave the recipe of constructing this operator, that means that Hamiltonian operators, from the expression of total energy of the system. So what is total energy? Total energy will account first the kinetic energy. Kinetic energy of what? All subatomic particles. So in atom, we will consider that the electrons and nuclei is there. So kinetic energies of electrons and nuclei of an atom will be considered for the total energy of the system. In addition, attractive potential energy. We know that that any particle has the kinetic energy as well as the potential energy. So in this case, to get the total energy, we need to consider also the attractive potential energy of what? That again, electrons and nuclei. And if attraction is there, already some repulsion also will be there. So repulsive potential also will be there for the consideration of the total energy. That means repulsive potentials again from the among the electrons and nucleus will be considered individually. That means nucleus to nucleus, nucleus to electron, electrons to electrons, in this way. So there, in these quantum mechanical models, what I told, this is very complex equation, will not discuss in this class. In higher class, it will be discussed. That means this Schrödinger equation. Only you have to know there is some two term is there. That is the E and psi. That means in Schrödinger equation, two mathematical term is there. One is E and one is shy. Up to this much only we'll know for this chemistry class 11 class for the quantum mechanical model of atoms. I hope that you clearly understand what is quantum mechanical model of atoms, what is the basis of the quantum mechanical model of atoms, and what is the difference between the classical model of atoms and quantum mechanical model of atoms, and also what is the history behind this quantum mechanical model of atoms. And also now we know that what is the Schrödinger